Okay, we are still in section 1.2. We are still discussing displaying quantitative data with graphs. We have looked at dot plots. We have looked at stem and leaf plots. And we are going to take a look at something called histograms today. Now, histograms is something that could easily be confused with bar graphs, so I want to make sure to just talk about the distinction between these two here real quickly. A histogram is reserved for displaying quantitative data. Okay, that's our numerical data where averaging the numbers would make sense. Okay, and a histogram is continuous, meaning your bars are right next to each other and they're touching. A bar graph is typically reserved for categorical data. If you think back to, I think we had in our notes maybe an example that surveyed 19 to 25-year-olds about how likely they thought that they would be, by the age of 30, having a salary that was above middle class, okay? And so those responses were categorical, and those words, those categories were listed along the x-axis. That would be put in a bar graph, and that's when there is a gap in between the bars, okay? There's a space in between, but it's all continuous with the histogram because we're talking about numerical data and we want those numbers to flow, from one to the other continuously, okay? So that's the difference between these two things. We're going to talk about a histogram today because we are studying quantitative data. And so a frequency histogram, okay, generally stems from a frequency table, okay? And so you're going to categorize your data into what are called classes, or sometimes these are referred to as bins, okay? And so this is the range that would hold like all the data values in between, okay? I'll demonstrate what I mean here. You can see in this frequency table that's provided for you here already, okay, these are our bins, and you can see this is giving us the bin width. Okay, now please notice that this is not a less than or equal to, but rather it's the first bin or class includes all the values from 0 up to 5, but it doesn't actually include the number 5. So I don't know what this data represents. We don't have any context here, but let's say that 4.99 was one of our data values. It would be included in this bin here because it's smaller than 5 but greater than or equal to 0. There were 20 values in this data set of 50 that fell between 0 and less than 5. Now notice where 5 is included in this next bin. So what you want to keep in mind is the left side of the bin, that number is included, but the right side is not included. Okay? And so let's just make up what these numbers are representing so that we have some context here. We're going to make a frequency histogram from this data, and let's just say that this is representing the number of states. Okay, we got 50 states here. We'll say this is the number of states versus the proportion of foreign residents in the state. Okay, so if we were going to make a histogram with this data, I already have my bins decided for me. So I'm going to make an XY axis, as you see I already have here on the paper. I'm going to try to evenly space this out as best I can, counting by 5s here. Okay, I'm going to go all the way up to 30. I'm going to go ahead and label this that this is the percent of residents born outside the U.S., okay? So this is the percent of residents who are in that state who are born outside of the United States, okay? And then this, I'm going to go ahead and just mark off counting by 5s here. This is going to be the number of states, which is the frequency, okay? So, let me just space this a little bit better. Sorry. Put this right back here. Just try to space this a little bit better. Okay. So then I'm going to go ahead and I'm going to make a bar that is going to go up to the frequency of 20 on the y-axis, and it's going to span from 0 to 5 here. Okay. Okay, you don't have to get rulers out or anything like that, even on the AP test. You do the best you can. It's fine. It doesn't have to be exact. They're looking for the, just the general idea here. So just try to eyeball it. Okay, so that's maybe roughly an example of a frequency histogram where we're saying, look, there were 20 states out of the 50 that had less than 5% of their residents who were born outside of the United States, okay? So once again, just to reiterate this, if, let's say, Ohio had 10% who were foreign born, my question to you is where is the 10% included, okay? Is that included in this bar or is it included in this bar here, okay? And please keep in mind, we said that when we're talking about these, that it includes the lefts, the bar includes the value on the left, it does not include the value on the right, okay? So if we're talking about where the 10% is, then it would be included in that bar right there, okay? Histograms always include the left boundary, not the right boundary, okay? Now, a few cautions here. Please don't confuse histograms and bar graphs. And we talked about this distinction right at the beginning of this video. Okay, we said that histograms are reserved for quantitative data and there are no gaps between the bars. Bar graphs are for categorical data where there are gaps in between the bars. Okay, it says here, another word of caution, use percents instead of counts on your vertical axis if you are comparing distributions, here's the key, that have a different number of observations. Okay, so if you're going to compare things and there's a different number of observations, you always want to switch to percentages. Like if you were to survey, I don't know, males and females, but you only sampled 50 males and 40 females, you wouldn't want to put counts there. You would want to change things over to percentages. Okay, and that's what this is referring to. And when we switch to percentages, by the way, okay, that's a relative frequency histogram, okay? And then another just word of caution here is just because a graph looks nice, okay, it's not necessarily a meaningful display of data, okay? It is possible, and you see this a lot in newspaper articles, and a lot of people that have a hidden agenda will try to skew their statistical data or the way they display it to fit the narrative that they're wanting, the message they're wanting to send here. So it is possible to manipulate your graph to influence the reader, okay? So this is just words of caution here. Okay, and graphs that are constructed poorly is another thing that you want to be cautious of, okay? We want to watch for that bin width dimension. Now, if you're wondering, like, how did they decide, because we don't have the actual set of data, like we don't know what all the individual data pieces are. With a histogram, you're given a range and then you know the count that falls in that range. But if you're wondering, how did they arrive at the fact that these classes or bins should be a width of 5, a lot of times if we're going to make a histogram, we might do that actually on the calculator, and the calculator will kind of set that up for us. But we'll just take a quick look on the next page, a little bit of doing this here. You can see in this example, the following table represents the average points scored per game. We're going to call that PPG for points per game for the 30 NBA teams in the 2012-2013 regular season. We're asked to make a dot plot to display the distribution of points per game, and then we're going to use the dot plot to make a histogram of the distribution, okay? So I kind of went ahead and made the dot plot there just to save a little bit of time, and I don't know how we would maybe describe this as somewhat uniform, maybe a very slight mild right skew, I guess, but it's kind of spread out quite a bit here, these points per game, okay? So if we were going to try to create a histogram, and there's not necessarily a solid right or wrong answer with how you determine the width of your bins or your classes, okay, I'm going to go ahead and just kind of group these as such. I'm going to group, maybe the first bin I'm going to say is going to go from 93 to 96. Okay, remember that means I'm not actually including 96 if there was one there. Okay, and I'm just going to try to split these into maybe 5 equal bins here. Okay, and so then the next one would go from 96 to maybe 99, 99 to 102, 102 to 105, and 105 to 108. And I can see here that in this first bin there are 11 dots, 8 dots, 5, 3, and 3. I will tell you, very, very rarely do I see people having to make a histogram by hand like this and determine your bin widths. Okay, typically what would happen is you would just put all this data in L1 in your calculator, and then you would go to second stat plot. You would turn on your stat plot and you would choose the histogram feature. And then typically we don't set our window ourselves. If you hit zoom, and I think option 9 is zoom stat, it will adjust a window. It will determine a good bin width and it'll show you the histogram. Okay, so we're just kind of saying, what if we had to do this on our own here? Okay, so I've got this set up here. The average points per game is along the x-axis. The number of teams, that's along the y-axis. That's my frequency. And we said there were roughly 11 in the first one. What were we saying? About 8 here in the next bin. 5 in the next one. We got 3 followed by another 3. Okay, something kind of like that. And I'm just going to note here, hey, it does look like it's skewed right. But do you see how it's actually a lot easier in this comparison to see that it was skewed to the right looking at the histogram than it was to detect that by looking at this dot plot here, okay? Okay, so the last thing on this is, why would we prefer a relative relative frequency histogram to just a frequency histogram? Okay, well, this means percents. Okay, so that means you would use percents instead of counts, and you would want to do this when comparing two groups that are unequal. Okay, if you were going to compare two groups, it is not fair to survey 100 freshmen and then 20 sophomores and compare their answers based on their counts and say, well, 75 freshmen, their favorite class is English, and let's say 19 sophomores, their favorite class is math. Makes it sound like, maybe I should do that backwards. But when you change it over to percentages, then it's a more fair, I guess I'll say, representation here of comparing two groups if they are unequal. Okay, so here we are again to a small assignment that you should be able to do these problems now at this point in